just day 2 on 2.4. We're going to spend more time on writing polynomials down here. Whoa, nice pen. I think we should not use that though. All right. Yesterday I glossed right over this. At the end I was talking about this finding rational zeros, and we reviewed this, and we are going to do this again today. We're going to list all the possible rational zeros. We're going to graph and find where those real zeros are. And then we'll completely factor the zero. And at the end, you know, we could have imaginary zeros. We could have irrational zeros. But this was really important, and I skipped right over it. It says the conjugate root theorem states that if a plus bi is a zero, then its complex conjugate a minus bi is also a zero. Remember we had things yesterday that looked like this, and we set those equal to 0, and we got x equals plus or minus the square root of -1, which we wrote as plus or minus I. It's just saying anytime you have an imaginary root like that, or a conjugate like 2 plus I, it's, I shouldn't have said conjugate, or a complex root like 2 plus I, its conjugate will also be one of the roots. That's because when you multiply those conjugates together, you will get a real number. And we didn't have any imaginary numbers in our original polynomials, so therefore they have to come in pairs so they cancel each other out and make a real coefficient. All right. So this one says, and this is what you will have to do on the quiz. It says, write a polynomial function of least degree with real coefficients in standard form that has 0 and 2i, square root of 2, times I as zeros. So they're telling us there's a 0 at 0, and there's 1 at I square roots of 2. I'm going to put the I out front so it's less confusing. If this is true, you are to know that there also has to be 1 at negative I square roots of 2. Okay? Then when you write out the factors, you have x minus 0, x minus I square roots of 2, and x minus negative I square roots of 2, which would become plus I square roots of 2. Does that seem okay? If these are, you'd have x minus I square roots of 2 and x plus I square roots of 2. Now, x minus 0 is just an x, yeah? But we're going to write this in standard form. Now, I am not going to make you write all of your answers in standard form because it's a lot of foiling of it's a lot of unnecessary foiling. But it's also the reason I'm not assigning some of this in Delta Math. But these, I want you to get foiled together so that we do not have any complex numbers in our answer, only real numbers. So if we multiply these together, we get x times x is x squared. Does everyone see that these two messy inside and outside answers would undo each other? One would give you a negative x times I square roots of 2, and one would give you a positive x times I square roots of 2. So that would be 0. Everybody okay with that? Those really messy ones? All right, so then we just have the last term times the last term. A negative I square roots of 2 times a positive I square roots of 2 would be a negative I squared. And what do we get when we multiply square root of 2 by square root of 2? 2. So we ended up with an x squared minus I squared times 2. Well, what is an I squared? Remember, I was the square root of -1. I squared was just -1. So this is x squared minus -1 times 2. What would that become? A plus 2? Everybody okay? So we get x squared plus 2. And then there was this x out in front that I lost along the way here. So I would say you could leave it like that. Standard form, we would distribute it, which on this one is easy to do. Whoops, I lost the 2, sorry. All right, so again, they told us 0 and square root of 2i. That means we knew negative square root of 2i also had to be a 0. We wrote them as factors, then we FOILed it together, and they wound up with this in standard form. You don't have to get all the way to standard form for the ones we're going to do in a minute here. This is a lesser fun example here, but it says if we have an x plus 2i is a 0, that's what they told us. Find all complex zeros of this given that x plus 2i is a 0 of the polynomial. Then write the linear factorization. If x plus 2i is a 0, its conjugate x minus 2i is also a 0. When you write that, remember it's always x minus the 0. So this is x minus the quantity 2 plus I and x minus the quantity 2 minus I. Ooh. So can we get rid of those inner parentheses by distributing that, guys? It would be x. If I distribute this negative, I get minus 2 minus I. Everybody okay? What if I distribute this negative back here? That one becomes x minus 2 plus I. Is everybody all right? Then we have to FOIL that together. No crying. It's pre-calc. We can do this. We're going to distribute this x to all three terms back here. We're going to have an x times x is x squared. X times negative 2 is negative 2x. X times I is plus ix. Then we're going to distribute this negative 2 to all three terms back here. Negative 2 times x, I'm going to write it underneath the other negative 2x, but you don't have to. Negative 2 times negative 2 would be a positive 4. I don't have anything that matches up with that, so I'm just going to write it out here at the end. And then negative 2 times this positive I would be a negative 2i, and I also don't have any plain old i's, so I'm going to write that out there. Then I'm going to go back one more time and distribute this negative I to all three of these terms. Negative I times x is a negative ix, and I'm going to write that under the positive one I already had. Negative 2, negative I times negative 2 would be a positive 2i. So write that one out there because it lined up with that. And then negative I times I is what, guys? Negative I times I is a negative I squared. I'm going to write it under the 4 because what is negative I squared going to become? Plus 1, right? Because it's minus negative 1. All right, so now combine my like terms, and you could have written it all in one big log line. It doesn't matter, but I lined my like terms up. There was an x squared right here. This is 0, this is 0, this is 0. So what? Oh, no. Just kidding. This one's not 0. Oh, my goodness. This is negative 4x, right? This one is 0, and this one is 0, and left at the back is a 4 plus 1 or 5. Whew. If we did quadratic formula on that right now, can anybody guess what our answers would be? Two plus I and 2 minus I, right? That's what we just did, was we worked backwards, okay? We worked backwards to get from the answers to the polynomial. Okay. Now they want us to do long division, and we're actually going to do long division. We're going to take this really disgusting polynomial we just got. It wasn't that disgusting. The really disgusting one is what we started with at the beginning of this problem. X to the fourth minus 5x cubed plus 3x squared plus 19x minus 30. We're going to divide this in. This is a great review. All right, x squared to become x to the fourth, I would multiply by an x squared. Now I got to distribute it to all three of those terms. So x squared times x squared is x to the fourth. X squared times negative 4x is a negative 4x cubed. X squared times 5 is a plus 5x squared. Then I'm going to subtract that all from the what's above it, the like terms, or I'm going to add the opposite if you want to change all the signs, which is what I do so that I don't mess up any signs. This better be 0, okay? That was the whole point. Now when I do this, I get a negative 1x cubed, and back here I got a negative 2x squared. Everybody okay? Did I do it right? Bring this guy down and I have a plus 19x. All right, let's see if we can try this one more time and see what happens. To get an x squared to become a negative x cubed right here, what do I need to multiply it by? A negative 1x, or just a negative x. So that will become a negative 1x cubed when I distribute it to all these terms. Negative 1 times negative 4 is positive 4x squared. Negative 1 times 5 is negative 5, and that has an x. All right, now if I subtract or add the opposite, I get a negative 6x squared plus 24x minus 30 when I bring this down. It's supposed to go in even. Does it go in even? What did we multiply by this last time? To get a negative 6x squared from this, we multiply by negative 6. If I distribute that through all of those, I get negative 6x squared plus 24x minus 30, which if I change this to subtract or add the opposite, it's all opposite, so it's just 0. Whew, okay. So what we just did was we said this times this would give us this great polynomial we started with. Well, can we factor just a little bit further this one? X squared minus x minus 6. Anybody know how that factors? That won't give us a 1, though. Does that work? A negative 3x and a positive 2x will give us a negative 1 in the middle? Okay. So right here, the other two factors are x minus 3 and x plus 2, which means the zeros were 2 plus I, 2 minus I. What do we get? 3 and negative 2 would be the last two, guys? Okay. Could we have graphed this and found 3 and negative 2 as real zeros? Yeah. Would that have been way easier than what we did? Yes. I just wanted to do it one time because I'm not going to make you do it this way. We're going to graph to find the other zeros. Okay. So this is practice writing. We're going to do one more with this disgusting 4 plus I business. All right, it says there is a polynomial, to write a polynomial of least degree that has only real coefficients It says in standard form, but we're going to instead do, as long as it has integer coefficients, the factored form is fine. That means I can't have any i's in my answer, but I don't have to FOIL it all out. All right, if there's a 0 at -4, tell me a factor. X plus 4. Okay, if there's a 0 at 1, tell me a factor. X minus 1. All right, but I can't write my last factor as x minus 4 plus I because it has an imaginary number. And if 4 plus I is a 0, there is also a 0 at 4 minus I. So, well, this is a factor, so is x minus 4 minus I. I promise we won't do many more of these today. Okay, help me get rid of the inside parentheses. What would this one say? Distribute that inner negative. Somebody? X minus 4 minus I. Everybody okay? Distribute this and we get what? X minus 4 plus I. Okay. Start foiling that mess together. If I distribute an x to all three of these terms, then I go back and I distribute a -4 to all three of these terms. And finally, a -I to all three of those terms. Anything gonna go away? We need all the imaginary numbers to go away. Is that gonna happen? I have a plus ix and a minus ix. And I have a minus 4i and a plus 4i, so those would take care of each other. What is this minus I squared going to become? Plus 1. So now what's left? X squared minus 8x, 16 plus 1 back there is 17. Did someone else get 17? Okay. So our factored answer is x squared minus 8x plus 17. We had to put it back together to get rid of the imaginary numbers. Standard form would mean if I made you FOIL these two together and then FOIL all that together to get an x to the fourth, blah, 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 blah. Okay? That would be standard form. If you made it this far alive, I'm happy, okay? I think we don't need to do any more. Okay. And I'm going to tell you right now that I did not put one on the test that's that cranky. Okay. Find all complex zeros of. You have this question? Okay. X to the fourth plus 8x cubed plus 16x squared plus 200x minus 225, given that 5i is a 0. Well, if I were to make you go back to yesterday and list all the possible rational zeros, what would we have to list? All the factors of the constant over the leading coefficient. All the factors are 225, right? There aren't as many as you think, but we're just not going to do that. If 5i is a 0, what did we just learn today? Has to also be a 0. Negative 5i. Okay. We're going to write the linear. Now, what they really want us to do is to multiply these as roots together and then do long division. But what did I say we could also do to find the real roots? We could graph it, okay? I could have you take time to graph it, I think. Yeah, get a calculator because you're going to need to graph some, but I put it in and I found a real zero. Can everybody see that screen right there? I found that 1 worked, and I found one out at -9, okay? So I found one at 1 and one at -9. I'm just going to save us the pain of typing that in, okay? So the other 2 were at 1 and -9. Now it says write the linear factorization. So linear factorization would go ahead and be x minus 5i, and we would leave it because it's a power of x. And then the -5i would be what? X plus 5i, and the 1 and the -9 would be x minus 1 and x plus 9. Now that is the linear factorization. And this one doesn't say that you have to have real coefficients, so we're just going to stop. And where did we get those last 2 again? We graphed, right? Okay. Complex includes real. And so, yes, these are all the complex zeros, and then write in linear form. So 5i was 1, -5i, 1, and -1. That's a great question, Jada. Let me go back to the slide from yesterday, because that's an important thing that you should make sure you have highlighted in your notes. Right here, it says any real number is also a complex number. I don't know why it's so tiny in your notes, but complex includes real and imaginary numbers. All right, where was I at? Okay, this one, numbers 4 and 5 say write each function as a product of linear and irreducible quadratic factors. That means if it doesn't reduce any further, we don't have to. It means you need real coefficients, okay? And be the product of linear factors. Oh, then we do have to reduce it. Yeah. And then list all the zeros. Okay, start by graphing. So, number 4, throw that into your calculator. I have no idea if a standard window works. Well, it helps us find 2 of them anyway. Anybody know where they are? Did anybody check them? Remember, you can also look at your table. Looks like there's one at 4, and then there was a -1. Looks like -6. Okay, 4 and -6. What did we learn to do that would help us get this down to a lower degree? Can we put the 4 and the 6 and do the successive divisions, right? Successive synthetic divisions. That's easy to say. Okay, so across the, I just picked 4 first. Anybody want to do -6 first? It won't matter. 1, 2, do I need any placeholders? Okay. It's supposed to come out 0, right? Because it was a root on the calculator, was 0. So bring down the 1, multiply is 4, add is 6, multiply is 24. I think that's 9. Did I do okay? 9 and... Is that right, guys? I think so. 4 times 9 is 36. Holy moly. 14, 3, 4, 54, 108, 216. What do you know? All right, then we have to do what still? then negative 6 times 0 is 0, add to 9 is 9, negative 54, 0. Whew. What does this mean at the end? That's a constant, that's an x squared, so we're left as our depressed polynomial is x squared plus 9. All right, so the answer to part A, right, is a factor, because x squared plus 9 does not factor. Everybody okay with that? X squared plus 9 does not factor. What were the other two factors? X minus 4 and x plus 6. Good job. Okay, product of linear, and this is irreducible, so that's, now we have part A. The linear factors are these two, and this one is an irreducible quadratic factor. All right. Then B says write as linear factors. Well, we really have to find the zeros to do that. I'm going to do part C first. The zeros were 4, negative 6, and anybody know how we find those zeros? If we set x squared plus 9 equal to 0, we get x squared equals negative 9. If we square root both sides, we have to remember what? Plus or minus, and the square root of 9 is 3, and the negative makes it I. So we have plus or minus 3i. So there's our 4 zeros. Now, if they want it as linear, how is x squared plus 9 going to factor? We just figured it out. It's going to factor, yeah, plus and minus 3i. And x minus 4 and x minus, or plus 6. I would ask for one or the other of A or B. I would probably not ask for both. I don't want to confuse you with all that vocabulary if I were to put that on a quiz. All right. We have one more. Let's practice what we did yesterday. Plus or minus the factors of the constant over plus or minus the factors of the leading coefficient. What are the factors of 6, guys? 1, 2, 3, and 6. The factors of 3 on the bottom are 1 and 3. So what is that complete list? Plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. If I put them over 1, but what if I put them over 3? I get a 1/3. What else? 2/3. 3/3 is already on my list, right, as 1, and 6/3 is already on my list as 2. All right, that was just a review from yesterday. If you graph it, I'm not going to make you do it. It comes out at 1. Everybody see that it has only one real zero? At 1. So what are we going to do next? Some division. I put a 1. I think we need a placeholder though. 3x to the third plus 3x squared plus 0x minus 6. Everybody okay? Why we have a placeholder there? Bring that down, multiply, add, multiply, add, multiply, add. Did anyone else get that? Okay, there are no more real zeros, so how would we have to find the other zeros? Yes, this is a 3x squared plus 6x plus 6. Could we reduce that before we do the quadratic equation? We could take a 3 out. X squared plus 2x plus 2. Some of you are thinking that factors, but does that factor? Factors of 2 that add up to 1, no. All right, doesn't factor. Is this 3 a 0? Was there a 0 at 3 when we looked at this graph? No, that's like a stretch out there, okay? We got to do quadratic formula quick. A we're using this equation right here. So A is 1, B is 2, and C is 2. So we'd have x, do I need to write the quadratic equation on your notes again, or you got it? Should be in there from yesterday, but it's negative b plus or minus square root of b squared minus 4ac all over 2a. It's supposed to be in your brain. Opposite of b would be negative 2 plus or minus, it's a positive 2 squared, so we really don't need parentheses if you don't want to use them. 4 times 1 times 2 all over 2, which is a negative 2 plus or minus the square root of something over 2. It's negative 6. Someone else get that? 4 minus, I don't think so. I think it's negative 4, right? Isn't this 4 minus 8? No worries. I was going with it. Negative 4. Oh, that's a little bit nicer because what is that top line reduced to? Well, actually, yeah, let's rewrite it. This would be negative 2 plus or minus, what is the square root of negative 4? 2i. And it's, if it's all over 2, we reduce each one by 2 and we end up with what? Negative 1 plus or minus 1i. Does everybody get where we got that? We have to reduce the 2 into both of those things. All right, what did they ask? Oh, okay. So the irreducible factors part, we had a 3 and an x minus 1, and then we had the x squared plus 2x plus 2. That didn't reduce. And part C was all the zeros. What were all the zeros? The 3 was not a 0. The zeros were 1, negative 1 plus I, and negative 1 minus I. Does that work? We got 3 of them. Were we supposed to get 3 of them? Yeah. All right, and nope, that was part C. Part B, can we just be lazy? Write x, okay, there's a 3 out front. We should put that 3 out front. There's a x minus 1, and then I'm just going to write extra parentheses, x minus negative 1 plus I, and x minus negative 1 minus I. I don't want to deal with getting rid of those extra parentheses and confusing you. All right, the good news is it's not going to be that hard on the quiz. That's the really good news. All right, I promise. All right, can you look at 11A? I was going to assign these as practice, but let's just do them real fast together, and then your only homework will be Delta Math. Write a polynomial function, and I don't care about the standard form business. What are the 3 zeros they list right here on number 12? Square root of 5, negative square root of 5, and 7. So list those as factors, guys. List those as factors. What would that look like? X minus square root of 5, x plus square root of 5, and x minus 7. Did you find it? All right. If I said you had to have rational integer coefficients, we need to FOIL those two together. X times x is x squared. This is going to be a negative 5 square roots of x. That one's going to be a positive 5 square roots of x. Gone. But at the end, we get a negative square root of 5 times square root of 5, which is what? What's square root of 5 times square root of 5? Just 5, right? And it was negative. Now this one would not be that bad to write in standard form. We'd just FOIL that together, but I say we stop. Is there another circled problem on this page that we can get out of the way? 14? All right. So what would negative 3i, or negative 4/3, I don't know what I'm saying. Negative 4/3 would look like as a root, you'd have x plus 4/3. Everybody okay? For a negative 2i, you'd have x plus 2i. Are we done? If negative 2i is a 0, what else has to be a 0? So we have to have an x minus 2i. Okay, we have to FOIL those two together. So we get x squared minus 2ix plus 2ix is gone. At the back, we get a minus 4i squared. What happens to a minus 4i squared? Plus 4. So we have an x squared plus 4. And an x plus 4/3. Now, I'm okay with that. Anybody know what we could do to make this look nicer? Yeah, we could make that a 3x plus 4, because it would still have that negative 4/3, right? I don't care. Either one of those I would take for that question because it was just writing one. Is there another circled one, or can we be done? What's the last one? Oh, we can do this one. This is an easy one. How do you write a negative 2? X plus 2. Multiplicity 2 means you put what? A squared. How do you write a 0? X out front or an x minus 0 back here? I don't care. And a 3? X minus 3. Oh, thank goodness. I thought you were going to tell me 16 was what? 12? All right, I have extra practice, but we're just going to go with this. Delta Math, finishing 2.4 in review. I hope I didn't assign anywhere you had to write in standard form. I'm almost positive I didn't. So the homework is just Delta Math. What else do you need to be finishing up, though, because it's due Tuesday? We got to look at the review packet, but the slides, too. Do you remember the slides? Okay. So look at your review closely and see what you need me to do. And make sure your Google Slides are about done.